So good morning, good afternoon, everyone. Thanks for being here and join us to this Grid Flexibility webinar. Thanks again for the distinguished speakers we have here with us, Tal, Fei, and Yael. Being part of this webinar, that's been really impactful and what makes this really unique. So thanks for joining us. For those that are less familiar, I will quickly brief and introduce Ignite Spark, which is a non-profit organization that dedicated to serve as a hub, as a community for the whole ecosystem of energy innovation in Israel and beyond. And we work toward develop the next energy tech entrepreneurs by creating values and creating initiatives like that, like the events, like webinars, venture creation programs, projects, and also a kind of market exploration reports. We have three sub-communities that are part of this academia, the industry, Women Energy and Ignite Internationals, all dedicated with the same visions and efforts. I really like to work with people, so if you are not familiar with what we do, you can feel free to scan this one or see this link in the chat and join us and be part of that. So why we're doing this webinar basically is it's a follow-up for the last Energy Tech Week that we have done in June. Remark one of the big milestones in our organization, and a part of it was having roundtables with our dear partners from E.ON, specifically about this topic, creating a deep dive conversation about one of the most important challenges towards energy innovation, which is the grid. You can check this article, find out a bit more about what we discussed over there. Some of the key takeaways are addressing the regulatory frameworks, the challenge to kind of getting the data, and much more. Feel free to delve in. Feel free to ask any questions. We're happy to address that. But we have a whole webinar to explore that deeper. So after a short introduction, we'll have here Fei that will introduce their perspective from NREL, Yael Parag, Vice Dean School of Sustainability from Reichman, Tal, the co-founder and CTO of 257, and some open discussion to conclude. So without further ado, let's start and get deeper to the connection and what is actually grid flexibility. Faye, thanks for joining us. The stage is all yours.
Thank you, Shon. Just checking you can hear me correctly.
Perfect.
Okay, cool. Let me share my screen. Okay, you can see my screen.
Yes.
Okay, cool. First, yeah, thanks for including me into this exciting session. And today I will talk about some work from NREL that we are doing on the grid flexibility, focusing on the demand side. And we developed a tool called EdgeFlex. And I will provide you with more information about how we use EdgeFlex to achieve demand side flexibility, quantification, and operation. Since I am the first one to present, I will also set the stage what is the grid flexibility. So by definition, grid flexibility is the ability of power system to respond quickly and efficiently to any changing conditions. And these conditions can be resulted from generation fluctuations, load shifts, and also unexpected outages, and so on. And for the grid flexibility to achieve it, actually we can leverage three different aspects. First, from the supply side, we can do some flexibility. And from the network side, the grid infrastructure side, they can also be managed to provide some flexibility. And but for today, my talk is on the demand side. So we are doing research on the managing the demand side resources to provide the flexibility for the power system. And here, I would like to show you some real world examples. So you might know that in 2021, there is a very significant outage happened in Texas. And a lot of generators were tripped due to the extreme cold weather. Actually, studies after that event, many researchers conducting different types of studies. So from this paper, conducted by people from Texas A&M University, and they show that if we can apply like incentive-based demand response programs by leveraging like residential customers, it can reduce around 60% of outages for that event. So that means if we have effective approaches that can harness the flexibility from the demand side, actually that can provide a lot of benefit for the grid. And in the real world, we also have shown that like in California Bay Area, EVs has been used to provide flexibility. And in this particular example, they show that EVs are leveraged to reduce around 5 megawatt hour demand to mitigate the heat wave power surge during this event in 2022. So by leveraging this EV flexibility, they can effectively mitigate the possibility of the outages. So these are some real world examples. Now let's switch the topic a bit to our EdgeFlex concept. First, how do we define the flexibility, specifically demand side flexibility? So we consider demand side flexibility as a capability of demand side devices. So these devices can be building loads. It can also be like a rooftop solar storage EVs that are connected to these buildings to adjust its net power consumption. Here, net power because it can include the generation. So it can be a combination of the consumption and the generation. So if we can leverage this net power consumption to alter its pattern, it can actually provide a lot of value for the grid. And to quantify those, very simple, the flexibility can be defined as a range between the maximum power consumption and the minimum power consumption. This maximum and the minimum power can be calculated or can be estimated by many methods. So we can see there are a lot of work in this area. But eventually, if we can quantify the flexibility into the curve showing on the right side, it can like define how much this flexibility can be ramped up, the flexibility, how much it can be shifted. So by leveraging this, we can fully understand the capability from the flexible devices behind the meter. And with this information, it can provide enough visibility for the aggregators, for the utility grid operators to define appropriate programs that can recruit these customers and provide demand side benefit. And also we can define like appropriate control solutions that can manage these devices in the most optimal way. So with that, I will introduce our EdgeFlex tool. Essentially, it is a software toolkit that conducts grid edge demand side flexibility quantification and operation. Because in order to leverage the flexibility, we first need to quantify or estimate how much capability of this ability. So the first function of this tool is to quantify the flexibility. And with that, then we, depending on the use cases, it can be used to provide the different types of services for the grid and for the customers. So essentially, the tool can conduct the behind-the-meter visibility. It can quantify the flexibility. It also can provide like a grid network-aware optimization methods to managing both grid assets and behind-the-meter devices. And it can be used to support versatile applications. And so far, the bottom side shows some existing collaborations that we have with the industry. So we have already applied our EdgeFlex tools and capabilities in multiple utilities in the United States, and also worked with technology companies across the world to demonstrate this capability. Here shows some high-level overview about what it can be done for the grid operations. First, it can like be used to measure the behind-the-meter flexibility, and then it can be used to support both distribution grid and the transmission grid different applications. In the past, our applications are mostly focused on like aggregated network flexibility evaluation, voltage management, peak load management, and also affordability analysis. Another major use case that we demonstrated is resilience, because we can leverage the behind meter flexibility. It can be used to significantly improve the resilience in the grid. So here is more information about some successful applications that we already done. This case shows that in the past, we worked with a utility in Colorado, and we used our tool to maintain 0% voltage variation for a full all net zero energy community, and which has very high solar penetration, but we can leverage all the behind the meter devices, such as the AC, the watt heater, EVs, rooftop solar, and also storage. And we harness the flexibility from all of them, and we can first mitigate the over voltage issue, but also we can help the customers to achieve the energy saving. So in our real field demonstration shows that we can achieve an average of $4 kilowatt hour per day energy cost reduction during the peak pricing period. Another example is that we worked with a company called Surveillant, who is the ADMS vendor for many countries across the world. And we worked together with them to integrate our flexibility approach and using their ADMS to demonstrate how we can achieve self-heating distribution grids and use the DERs, distributed energy resources, to increase load support by more than 50% for a real system in Central Georgia. And another example is that we worked with a military microgrid. And in this example, we mainly focus on the building HVAC, is the AC systems. So we used this commercial building load to reduce the energy bills and help them to demonstrate that this can achieve by more than 20%. And also we can achieve 14-day resilient operations with significantly reduced cost. So here are 3 existing ongoing applications. We are still working on these, but they have different aspects. So this one we target at controlling the electrical water heaters for more than 200 residential customers. And in the second example, we are trying to use grid edge flexibility to create an orchestrated platform that can significantly improve the grid visibility and also improve community resilience. On the last example, so we will demonstrate how all the types of the resources in the grid edge can be harnessed together to provide a back power system services. So we are working with a utility in Hawaii to show how we can enable this operation. These are some very high-level examples about some successful and existing applications that how we can leverage grid flexibility. And now let me touch on the 2 important scientific parts. So first, we needed to quantify the flexibility. There are many different approaches, but indeed we can divide them into 3, which is also our EdgeFlex to offer. So first, which is the ideal case. If the utility operator or aggregator, they has a full visibility to the behind the meter devices, the residential devices, we actually can model the flexibility accurately because we can formulate the problem and then solve the flexibility. However, this is not realistic to do because usually we do not have that information. So with that, now many people are using AMI data to unlock the visibility by doing the data-driven approach. So we can use AI machine learning to do the load disaggregation, and then we can learn the behind the meter device behaviors. We already demonstrated that this can be effectively extract the flexibility information and help utility to define the demand response programs. But again, this is not a perfect approach. It is still an estimation. And also sometimes it is really hard to provide a very accurate real flexibility information. So now we are actually offering the 3rd application, which is to use federated learning, which can create a collaboration between the utility, aggregator, and the customers. In that case, the customer at the customer side, we can learn the flexibility by using some private data, but this private data will never be sent out from the residential customers. So they will always be kept on premises. But through the federated learning, we can still share some like the AI model parameters with the utility. In that case, we can learn the flexibility in the most very accurate way. So these are the three different types of functions that we offer to quantify the flexibility. After we have the flexibility, operation is really important, right? But the residential devices or behind meter devices, they are very different from some devices that utility can directly control or can directly operate. So we needed to define the right architecture to harness all this flexibility effectively. Here shows the architecture that we developed and we adopt. So for all the behind the meter or devices at the residential or commercial side, we can divide them into like three categories. First is that utility can directly own or operated devices. In those devices, the utility can directly control them. And there are also other devices which are completely non-visible or controllable to the utility or aggregators. So these are like uncertainties to the operations. But for other devices that they can provide flexibility, they can be controlled in an indirect way. We need to apply like a hierarchical architecture that can protect these devices' privacy, but also can manage these devices in an effective way. So our solution is a hierarchical decentralized method. And through this, we can harness all the flexibilities from this grid edge side and provide the values for the grid operations. So these are the very important scientific aspects that I believe for implementing the flexibility. Here, I still have like 2 or 3 slides to quickly give you some more context about some examples that we implemented. So here is the use case that we do for leverage HVAC load flexibility to reduce the energy costs. So in this case, we leverage the flexibility from the 436 commercial buildings. And then we conducted the study on a digital twin mode of the real microgrid. And in our case, we show that based on 1 week analysis, we can reduce the cost significantly. So if you look at this table, there are 3 columns. The baseline meaning there is no control at all. On the middle case, it is we applied the controls, but do not consider the demand side flexibility. So the control is mainly applied to the on-site generators. And on the 3rd column, it is we also include the flexibility into the holistic approach. And we can show that by applying the controls, we can reduce energy cost by 21.2%. And with the additional load flexibility, we can further reduce the cost by 5.99%, which will save another like $15K. So that shows the flexibility is very effective to reduce the cost. And here shows some example that we did for the resilience condition. Our target is to achieve 14-day non-interruptive operations. So there are 2 groups of results. On the left side, it is the result without flexibility. On the right side, it is the result with flexibility. The key findings is that by applying the HVAC flexibility, after 14 days, we can save the fuels a lot for the traditional generators by reducing the demand from the load side. And also we can supply all the critical loads for the 14 days without any issue. So this is a key message. This is my last slide. And in this case, we actually showed how we can leverage 500 net zero energy homes to provide values for the distribution grid. Specifically, we show how we can manage these 500 homes with the flexibility to mitigate the voltage issue. There are 4 different bubbles, and the top one is the one without considering any controls or any flexibility. And the last one is this is which shows the harnessing the flexibility of all the behind meter devices. So it can show that the voltage issue can be mitigated significantly. With that, I will just conclude my presentation to honor the time. And if you have any questions, feel free to put in the chat. I can answer at the end. Thank you.
Thank you very much, Faye. That was fascinating, and I think that even though it's short time, you've managed to really made it all very clear as possible. And we'll have more time for questions, so feel free to write the questions in the chat right now, or even a question that you can maybe through the chat as well. But maybe one question from my side, maybe to give kind of a perspective, and maybe how do you address the challenge when you even work with EdgeFlex or kind of other tools you have with such a different markets that every markets have a kind of different regulation, different incentives, how you adapt your solution and kind of the research behind that in a really short answer as possible.
Yeah, first, that's a very good question. I will make it short. So to quantify the flexibility, it is actually not limited to any regulatory or incentives. The flexibility is really the nature from these devices. But to operate, yes, we have to consider different incentive programs, different market schemes to make them effectively applied.
All right, thank you. I think we can address that maybe more later. Without further ado, I want to invite to the stage our next speaker, Professor Yael Parag, that in New York right now, and we luckily made to find her between classes to join us. So Faye, stay with us. We still will have more time for questions later. But thank you again for being part. And Yael, the stage is all yours.
Thank you. For sharing, I need to stop sharing the previous presentation.
Yes, Faye.
Yeah, thank you for inviting me. I'm very happy to be here and speak about this topic, which I'm very excited about. Can you see my presentation, Shon?
Perfect. Thank you.
Okay. All right. So, and I'm apologizing in advance that I'm in between classes, so I won't be able to stay until the end of the meeting, but yeah, I'll try. Okay. So, what I wanted to speak about today, it's adding a different layer to another layer to what Faye described, and I'm sure that Tal will will speak about later, the human aspect, everyday life in a flexible grid, what it means. And because we all agree that demand flexibility is very important and sometimes even crucial for grid resilience, we need also to understand why we use electricity and what for, and that's what I'm going to present today. I'm going to speak about why we use what we use electricity for and what the implication on flexibility, and also to speak about why we might stop using technologies that help us harnessing the flexibility benefits, and to think in advance how we might prevent this abandonment. Okay, so some of you maybe saw a few of the slides before. When we think about energy use, this is what people who consume energy look like. But actually, I think this is from the point of view of people who are working on energy, that's what they think. But actually, this is what people living in a modern society look like. They're not consuming energy, they're just living their day-to-day life. And what they do, they enjoy the energy services provided by different appliances. In this case, we're talking about the residential sector, so we're talking about appliances and behind the meter. And this is a wonderful quote that I keep bringing up, which I think is very insightful. Amory Lovins from the Rocky Mountain Institute says, people don't want raw kilowatt hours or lump of coal or barrel of sticky black goo. They want hot showers, cold beer, comfort, mobility, illumination. It is like when you go to the hardware store looking for a drill. What you really want is not a drill, but a hole. And why do you want a hole? Asking such questions is a first step in good design. So while a lot of the technologies that estimate the value of the flexibility looking for the best drill, I'm asking why do you need a drill? What is a hole? So for example, this is an energy service. chilled beer, and the same service could be provided by clean or dirty fuel. But from the point of view of consumer, he does not know what the mix that provided this service, but he wants a cold beer. So when we social scientists speak about energy and consumption and demand, we're speaking about energy services. Energy services are the benefits provided by energy. Okay, and while the wonderful and sophisticated tools that we heard and we will hear later, which do an excellent mapping of the resources behind the meter and the potential for flexibility in terms of how much we can harness, we need to remember that behind every curve are people running their lives. And we need to make sure that the potential for flexibility really matches the real life constraint and opportunities. So one way to think about it is to do a mapping of the appliances that provide the services behind the meter. So we can make here a distinguish between appliances that provide the service only after they have finished consuming energy and appliances that provide the service while consuming electricity. Okay, so air conditioner, TV, heaters, refrigerators, just to name a few, the service that you enjoy is while the electricity is being consumed. Although there's some buffer capability, for instance, if you want to have half an hour, if you have a supply interrupted for half an hour, the refrigerator will keep the cool, but it won't provide the service as such. So there is some buffers that prevent heat or cool to getting lost. But if you're watching television, you cannot interrupt this because the service is provided while consuming energy. And there are many appliances that provide the service only after they have finished consuming the electricity. For instance, the oven, what you want is cooked meal. So you need to do this process of consuming electricity to cook it. But once the consumption is done, you have the service ready. So you have this, for instance, water heater, washing machine, but also dishwashers and electric vehicle chargers. Okay, so this is one way to understand where to start understanding flexibility from the point of view of consumers. Now, when we continue with this typology, we can also think about appliances that are flexible while running and appliances that are inflexible while running. For instance, you can stop AC for half an hour and continue later. Also with water heaters, charging cars, etc. But there are some that are not flexible. For instance, you cannot stop an oven in the midst of the operation because if you're baking a cake, it will be destroyed. You cannot stop a washing machine while running or TV while running or dishwashers while running just because the dishwashers and washing machine will be ruined, okay? But from the point of view of flexibility, we need to put this demand flexibility and appliances flexibility on the services that we're interested. We are interested in load shedding or peak clipping, meaning shutting down the operation of electrical appliance at certain hours. Again, now we need to think about the service, the benefits, and what is flexible in terms of providing the service. And load shifting, and more and more we'll need the load growth when we're moving to higher solar shares in the in our electricity mix, okay? Now, let's put the appliances on these needs of flexibility. What is flexible? What is not in terms of appliances? Yeah. And then we need to understand what would be the implication for consumption of energy services if we, for every service of flexibility, be it load shedding, load shifting, and growth, or how will changing the operation time of appliances affect the dynamics of everyday life? And for that, we need to understand what is the dynamic of everyday life. While many technical people will look at the appliances, I'm looking at the services. So it's not about the oven, it's about when I need to, when dinner needs to be ready. And this, of course, is something related to the family structure, the composition of ages, how my daily routine runs. It's about when I need to do shower, for instance, hot water. okay? When I have to do it, when I need it. Clean, clean clothes, clean dishes, having fun, enjoying the leisure of watching television together, chilling our food, having warm home, going to travel anywhere. So all of these are energy services that supplied by the appliances that we are aiming to use as flexible load. And we need to understand where there are interfaces and when there are overlaps so we can harness this flexibility. Now, I think we all agree that in order, in particular in smart grid, flexibility to some extent could be delivered by people doing stuff when we need them, when we give them the right cue. And then we need to think about what the cues are. But we also agree about automation because we cannot expect people to go and change behavior or do stuff just because they received the cue. So we, in social science, we are looking for what influence the practice, the day-to-day dynamics. And we have here a list that I'm sure you're all familiar with. It's price, it's the social norm, the values, the regulation, the market structure, education and awareness, the know-how. Believe me, knowledge and know-how are one of the greater barriers for engaging individuals in a flexible grid. The effort required, the duration of effort, is it only for half an hour? Or do I need to shut down or reduce the temperature of my air conditioner for 2 hours? So all of these things, I think we all know that they affect human willingness to participate in the grid. The question is who is affected by which signal and how we tackle together. I mean, we go on all of these. We aim to reply all of these practices in order to, or things that influence our behavior when we plan an intervention. Now, what I wanted to introduce now is the idea of a technology abandonment, because we see here many technologies that can provide flexibility. So the domestication theory is a theory developed by Silverstone, Haddon, Morley, and others. These are leading authors in this theory. It was developed in the 80s, and it was about television, the use of media before social media in the 80s, okay? So the domestication theory argues that technology must be integrated into daily routine, values, and practices to survive, okay? And we're talking now about the technologies that provide flexibility. Adoption, meaning having it or buying the technology, is not the same as integration. A device may be purchased, but never truly become a part of everyday life. Think about your home and the appliances or technologies that you have available, but you never use, although they might help you do things better. So again, counting how many appliances are behind the meter does not mean that they're integrated into day-to-day life. If a technology disrupts routines, conflict with norms, or requires too much effort, it risks abandonment, okay? Think about elderly people or just young people and what they're willing to do and what are the routines and what is even automated technology might implies for the day-to-day life. So smart appliances, which are crucial for energy management, are often unused because they require complex apps, while a simple plug timer fits more naturally into routine and the household residence. And these things are very hard to be incorporated into the very sophisticated models like NRELs, and like others. And we need to think how we can do that, how we ease their integration in day-to-day life, okay? When we look at the reason why people abandon technologies, we see that they abandon it due to technical reasons like poor performances or performances that don't meet their expectation, reliability issues. Sometimes it's hard to use, it is broken, it's incompatible with other technology, or it is out of date. It might be economic. reasons like ongoing cost outweigh benefits. There are cheaper or better alternatives, in particular when we speak about electricity generating PV on rooftop versus buying electricity from the grid. So why do we use one and not the other? A very strong emphasis on social and cultural aspect. Sometimes technology does not, no longer fits norms. Maybe there is stigma. Maybe it has to do with loss of status or novelty. If you want to be a leader and everyone else has a technology, you might abandon it. We also see differences in the way that electricity is consumed between different groups. In my research, for instance, about Israel, we saw that in terms of charging electric vehicles, Orthodox communities or people who Shabbat observing have a distinct way of consuming electricity over the weekend or during the Shabbat. And this affects also the willingness to charge EV. So they are not so much affected by the price signals because they are led by other norm of behavior. So this needs to be acknowledged as well. There's, of course, a behavioral and psychological reason for abundant technologies like fatigue, too much to do, overload, privacy or trust concern. Privacy is a big one and trust is a big one. Who has my data? With this load aggregation, people can know exactly what you're doing in your home, and maybe this might be intimidating. Sometimes the context change, life stage, having children or children left the home, the lifestyle or policy regulatory shifts that make the decision that were previously suitable no longer appealing. So people discontinue technology when the perceived burden is greater than the benefits. And as people who look at flexibility and try to understand what happened behind the meters or people who use this flexibility need to think about both about the burden and the benefits and try to integrate them cleverly into their appliances. So I think that we all agree that automation is the key for unlocking flexibility in a meaningful way to the grid. And technologies like smart thermostat or automated DR programs will succeed if they fit into household routines, meaning don't interfere with dinner or comfort, for example. Align with values. It might be saving money, but it might as well be sustainability or other thing. They are trustworthy and invisible. In automations that does not require daily micromanagement, but rather do it for you. So it is key, and it will be successful if people and the energy services they use and need are and the constraint are considered. And as you see here, I added people to the smart home diagram. And again, if you look at most of the visual representation of flexibility in smart home, you'll see appliances, you won't see the people who use them. So with that, I'll end. I'll just say that recently we published a report about residential demand management from the residential sector. This is a literature review, part of a larger research, which we still continue. So if you want this report, I'll be happy to send it over to you. We're doing now also a model about residential flexibility. In Israel, try to estimate forecast of residential demand and to evaluate its flexibility in under different circumstances. And if you want, I have a list of publication on flexibility, residential flexibility, which I'll be happy to share with you. And with that, I'll end. Thank you very much for listening.
Ooh, wow, it was nice and really refreshing to see, and I think it was super important to hear a bit what is behind and how when we address solution or build solution, how we should think about the people behind that and what they consume, because eventually that will what will affect if they will use those solutions or not, and if they will adapt the technologies, eventually if they see the value. So thanks, Yael, for this perspective. I think it's really connecting what we saw before and what we see and we will hear very later. If someone has any questions for Yael, that might be a good timing to do so. Feel free either raise their hands or either the chat. Great, we see a question. Is residential or commercial demand a bigger component of the total grid demand?
It is, but it really depends in what hours and what season. So sometimes the majority of the load comes from commercial and industrial sectors, and sometimes the residential load can get to even 50% of the total load. So this changes throughout the hours. But as Fei started her presentation with the need to mesh supply and demand on a really milliseconds or on the second basis maybe, the questions are in what time the residential, what time in terms of the constraint of the generation provided by generation. So if you look at the duck curve, the residential load increases simultaneously to the decline in solar generation, and that's a challenge. I hope I answered in a brief way.
Perfect.
Yes. Yeah, thank you.
Thank you very much, Or, for the question and yeah, for the answer. If you have more questions, feel free to address that, and we'll share it also more information of Yael, Fei, and the representative on mail, so you can reach with them also later of that. So we're right on time, a bit above the schedule, so I'm happy to invite to the stage after, and I think for the first time, maybe presenting with us at least, we'll be here more about the background. The co-founder and the CTO of 257, a new emerging interesting startup. Tal, the stage is all yours. Thanks for joining us.
Thank you so much. Thank you, Shon. Thank you, Fei, Yael. What an awesome crew. Do you hear me well?
Perfect.
Yes. Okay. So I will jump right in. It feels like I couldn't ask for a better set the stage than Fei and Yael. Obviously, we have a problem. Obviously, the grid, like any other network, is a super congested network. And the only way to manage congestion is by understanding the supply side and the demand side and create tools to flex that. And everyone touched on that. I want to maybe take it up a notch and explain a little more how do we see the problem, but again, very much aligned. So 257 is a data and AI startup. We're heavy. It's an American company, but with big focus in Israel. We operate in the American market, but as I'm Israeli and large part of the team, we have a warm connection to Israel. So what do? We are harnessing a lot of data and building AI models to under the main vision to transform the resi energy market. What does that actually mean? So if we look at the overall resi market, the residential market, as opposed to the CNI market, the commercial and industrial, in the next decade, the United States is going to spend north of $5 trillion only on household or homeowners are going to spend north of $5 trillion on advancing different homes. And this is a combination between fuel and equipment, buying new EVs, insulating a roof, replacing an HVAC system, installing an induction stove, or installing rooftop solar. All of that is, in my mind, an advancement of the energy nodes in the residential sector. However, all of that is an extremely inefficient market, and there are many ways to explain that inefficiency. But if you look at overall dollars spent in that market, and this is clearly an illustration, but if you take out the equipment cost and the labor cost to install it, there's a very large part. It depends on the different sectors, but it's roughly 30% of the overall cost, that what is called the soft cost. This is cost that goes into not the actual equipment and not the labor to install it, but the communication to find the right people, to explain it to them, to apply for a permit, to get a loan to fund that. Anything that is not, again, the actual device or service or electrons that you're looking to buy. And we think, like just observing any other network, same thing applies to transformation, as Uber played in the market, in the taxi market, trying to optimize the market, or CDNs that are playing in the internet market. You need to understand very well the two sides, the supply and demand, and then you can start to lower the cost and optimize the performance. So how do we solve the inefficiency? We need to remove the guesswork. We need to make sure that homeowners knows exactly what is the best product that they should buy in order to lower their cost, become more green, or optimize anything that they would like to do. And any type of provider, be it a utility, a solar company, a battery company, a generator company, will know exactly which homes would benefit the most from the product. Yael mentioned earlier is that one of the biggest problems is people are frustrated that they did not get what they expected to get. Those are extremely expensive products, north of $30,000 to install rooftop solar, $15,000 to install a power wall, a battery, a whole home battery. Those are expensive products and very hard to understand what exactly it would be the long-term impact of that. Removing the guesswork using data probably will be, in our mind, one of the biggest drivers to lower the cost and increase adoption of those products. So how do we do that? We create a digital twin for every home in the United States. So there's 130 million homes. There are many amazing research done by NREL and by any other research department under the Department of Energy and others that are creating different models. Our assumption is that using machine learning and AI models, if we would know exactly what happens on every home on 123 Main Street and on 71 Broadway, exactly what happens on every home currently and what were all the different events that led to that moment, we will be best suited to predict the future. What will be the likelihood that if temperature drops in 10%, that home will install so-and-so, and what will be the impact on cost? So what do? We collect all of those data points available and build this representation for each and every home in the United States. Without getting into too much details, we combine a lot of different data sources, public ones, but the most important point, in order to train many different models, we rely on actual private data, actual usage, solar installation, battery installation, meter data, load profile, outage data, things that are actually observed in the market that allows us to optimize all of our models and reinforce the learnings that will allow us to get to a better prediction. As we always like to say, there is no shortage of data. I'll show it in a second. All of the data is available out there, but it's very hard to see the forest from the trees. Or in my example, to take the data and convert it into insights. So just to name a few, if we process, we're doing image processing on every satellite image to understand the state of the roof and the solar array and the impact of it, trying to guess the impact, looking at any real estate record, any type of tax record, any utility outage map, and any transformer and feeder and substation data that we can get, any electrical service upgrade to understand how many amps every home is getting, any car registration, to know who has an EV, any weather data to understand fire threats and hailstorms and anything else that may impact each and every home, and so on and so forth. More and more data sources. Back to what I said, there's no shortage of data, but it's very hard to take all the sparse data and to understand exactly what do we do with this. So we take all of that and build what we call the 257 digital energy twin. What do we do with all of that? This is, for lack of a better term, this is a database of records for every home. On top of that, we build a B2B supposed to be B2B, not end, B2B software platform that is built for the energy market. So we don't sell to consumer. It's not a B2C product. It's a B2B. And we sell to any provider in the market, either companies that sell services to homeowners, like an electric utility, a retail electric, or others, or a company that sells product like solar, battery, generator, HVAC, EV, any other large energy consuming product that would find itself or should find itself in a homeowner. The specific product that we offer has three components: an analytics solution that allows you to do a market research and to analyze it, a tool that allows you to target the individual homeowners, understand exactly who is about to buy the product and who is more relevant, and I will show that in a second. And then the last one is other tools that helps you actually communicate with those individual homeowners. A fun thing is that a product that I'm about to show you in a second is a pre-release product that in Thursday this week we're gonna unveil that to the market. And the product will be an AI agent for energy. And I'll show you in a second what does that mean. But just as a quick preamble, as an example, a bit of a joke, but an example of what the world looks like before this product. So if I would go and I could be anything from a utility that is looking to flex the load or to understand the arable homes, or someone to sign up to a VPP, or a solar installer that try to find homes. And again, just for shits and giggles, I would go to ChatGPT and I would ask, I'm looking to find homes in a given territory that has a specific configuration, yada, yada, yada. And then the answer that I would get would be, frankly, I cannot really answer you. I don't really know how. I don't have, this data is not publicly available. I don't have the exact addresses, the exact homes, and please go into other different data sources to get that answer. Obviously, this is a total fail. So with no further ado, please meet our new product that we're launching, which we call Pink. You will see in a second why, just hint, because it has a lot of pink. And I'm gonna demo it to you. So quickly, yeah, this is the drum roll moment. Again, this is a pre-release product. Please be gentle with me. Demos have failed in the past. I hope that this will not, but it happens to the best. So I'm logging into our product, again, Pink. And now I would ask, again, the chat interface that I'm sure you all use many, many times. For example, I'm looking to sell rooftop solar in the, I don't know, tri-state area. Please show me homes likely to install solar. Okay, I'll start here. And what I would get here is what essentially happening here is that we're querying our exact data. This is not US Census, not an EIA, or any type of aggregated model. You're querying actual raw level data of the individual. Thank you very much. You're querying the individual home. So you see, for example, that I found 233,000 homes that fit the bill. Now let me just start to filter that. Specific filter down to homes that has, I'm gonna play on Fei's comment earlier for homes that I would like to see if they have controllable load. Home that has whole home battery or an EV or a generator. So now I will see only homes out of those 233. I will filter it down only to homes in the tri-state area that we believe that will install solar. So again, I jumped over earlier, but we build a model to predict for every home in the United States, 130 million home, what's the likelihood that any event will happen? Solar installation, outage, roof would leak, they will buy an EV, they will move, whatever. So for example, I saw homes that have an EV battery or a generator and do not have solar, probably would like to install solar. Now, for example, I will say, okay, try the same for California. So I will shift that exact same query to California, and maybe I want to say now filter it down to homes that had a power outage in the past month. So for about 2,000 utilities, we process real-time data on almost minute by minute to know exactly which homes had an outage in every moment in time. So for example, again, I'm going to try my luck here. And what you see here, for example, I clicked the LA County or Santa Barbara County, and you can see it's a bit hard to see in the screen share, but you can see a random street. We're walking, Yael mentioned that earlier, but we're working a very, very fine line here and a delicate dance between sharing super robust data and maintaining privacy. So you will have no way to extract raw level data here. However, we want to make sure that it's clear that this is not aggregated, it's not guesswork, and it's not estimated by zip code or penetration or stuff like that. So for example, in Santa Barbara County, we will show you all homes, and we'll show you that those homes in gray are ones that maybe they have solar, maybe they didn't have an outage. We don't care what happens, but what we do know is that those homes in pink had an outage, have an EV battery or a generator, and are very likely to install solar. Now, maybe I'll start from scratch here, and I'll show you something else. Let's say that show me homes in Georgia and Alabama that have electric heat. So they use electricity for heating as opposed to oil or gas. No, for example, let's start with that. So I'm seeing homes in Alabama, in the South states that have electric heat. Now, of that, I specifically want to focus on overburdened community. Overburdened community meaning that people that are using a lot of electricity, and in this case, I'm going to look at low and medium income homes. So for example, I will say, give me only homes that got income below $80,000, $80,000, and use high energy consumption. So now I'm gonna filter all those homes to know only homes that their household income is below $80,000 and have a high energy consumption. I can ask, how do you define high energy consumption? So then it will tell me that we use 12,500 kilowatt hour, so 12.5 megawatt hour per year consumption per home, which is roughly 20% above the average. And again, just to explain what the hell is going on here, we train many different models to predict using weather, using a lot of different attributes to predict meter usage for every home in the United States. Obviously, it's a model, but we constantly correct it using AMI data and using other elements. So for example, I want to say, then it offers me, you want to filter it to 15K. This is pretty high. I'm sure the numbers will drop significantly. So now we're seeing only homes, again, the same thing. I've searched for homes in Georgia and Alabama that have an electric heat and the income is below $80,000 and their energy consumption is above 15K. I'm just gonna do the last thing here. Let's say that I wanna install a mini split here, so a mazgan in Hebrew. So I wanna only focus on focus on homes that are likely to install mini split heat pumps. So now again, this number will drop, and you will see the specific homes that we believe that for many different reasons, they don't have a duct system, they are eligible for ITCs or any type of credits or many other things, leveraging billions and billions of features that we learned about actual homes that installed mini split, and allows us to guess who are the ones that will install. I'm going to end with one last thing, is that we got to 33,000 homes here. And how am I doing on time? Okay, last point, 33,000 homes. But the important part is that we want to reach those homes. So we know that in those 33,000 homes, we know the name, the address, the phone number of 93,000 people that live in those homes, and we believe are decision makers of those homes.
Perfect. Tal, thank you very much. That was really, I think, the best way to end that into a practical way. So thanks for that, and great demo live even early. So good job. I want to use the last few minutes also for questions from the audience, also for Fei, and just like creating an open discussion. We have a few questions you can see here. The first one is kind of speaking about the computational overhead with twin approach may stress existing IP-based networks. There may be vulnerabilities, may be stress existing practices of this distribution level orchestration. Any thoughts on this direction? Make sure cyber-informed communication infrastructure to evolve for benefits of proposed twins. And I think the other questions is also speaking about data leakage and about sensitivity. So maybe Tal, you can mention, I know you mentioned that during, but maybe you can elaborate more about this specific matter.
Sure, I can start, and Fei, if you want to add from your perspective, obviously, or anyone else. There's many layers to it. One component, and maybe at a higher level, we put privacy first and foremost. Yes, there is a lot of data underneath that allows us to run those very specific queries. However, we spend a huge part of our time and our efforts on making sure that it's impossible, or at least as far as we would like, impossible to get to the raw data of everything here. I didn't complete my demo of what do you do with all of that beyond the nice queries, and then obviously the question makes total sense, is how we make sure that this data will not leak. I'm just going to say, and happy to talk to anyone afterwards, is we make sure very much that there is no way, we don't sell data. You will not be able to extract any type of personal identified information outside of our system. So that at a very high level. Specifically, I would say again, I spent almost 2 decades in the advertising industry or the media industry before that. That clearly have a lot of sometimes good, sometimes bad, but at least a lot of effort around privacy and user data. There are ways, if you think about privacy from the beginning and invest a lot in software, there are ways to obviously prevent from cyber attack, but also to collaborate between different companies of sharing data without exposing any personal identified information. I know this is a very high level answer, but this is top of mind.
Thank you. Fei, maybe do you want to address also how do you kind of working or with the challenge of leakage of information? I know there's more tools, but how do you face these obstacles when you're creating those analysis on with your tools?
Yeah, so the privacy is definitely a very key aspect, especially focused on the residential side. So that's why in my presentation I mentioned that when we quantify the flexibility, we developed the solutions that we can use federated learning, which means that all the private data associated with the residential customers will be always stay in their side. So there is no privacy or private data passed through to other entities, no matter whether it is utility or aggregator or others. So in that case, we can protect the privacy to the maximum extent.
Great, I see. Thank you. The second question we have also about data, how you train the model. I assume it's a challenge by itself. Tal, you've mentioned briefly that, but how you kind of getting the exact consumption data, that's a challenge by itself. Where you get the data to create a value from, that's I think pretty interesting to explore.
Yeah, so again, it's a very long answer just by virtue of the amount of data sources, but all the models behind the scene, first of all, are 257 homegrown models. We're not using anything off the shelf, predominantly using supervised learning models and image processing and a couple of others, but mainly observing events that happened, again, meter data and others, and trying to predict the future. Where do we get it? Through combinations of licensed data, licensed raw data, like satellite images, for example, that require processing, and or collaboration with utilities, solar companies, battery companies, HVAC companies, generator, and many others. We do not collect data from homeowners directly.
Mm-hmm. That's interesting. Fei, also when you work with partners, your collaboration is basically lean on the utilities or the company, the industry, right? It's never directly through the people, right?
That's true. That's true.
Okay, great. Cool. Any more questions before we close this up? I see for a little bit questions about the business model and main target customers from Daniel Ranani. Tal, do you want to drop that?
Sure. So I did mention, again, continue my shameless plug, but I didn't mention that this app that I just showed that about to launch on Thursday, it's already live, but we're going to make some waves on Thursday. It's free to use. Again, if I'll level up, our goal is to accelerate electrification. And we think that there are many ways to do that, but the one that we can make an outsized impact on is by trying to lower the cost significantly. How do we lower the cost? By creating democracy access to data. So allowing everyone, every utility, every solar installer, everyone to get access to the data. And in order to do that, if we want to practice what we preach, we want to give it for free. We obviously need to pay the rent. So how do we do that? We give the data completely for free, and that system, not the data, but the platform. But you would pay for it if it actually drove results or when it drove results. So if a utility is looking to sign up to a VPP, or you would like to move people to a time of use rate plan, or would like to install rooftop solar, or to find homes that had an outage that would like to get a whole home battery, whatever it may be, if you achieve your goal, and we are fairly certain that you will achieve your goal cheaper than what you would do that anywhere else, you will pay us for that savings. But you're only going to pay if it actually delivers the results. So we're trying to align ourselves with our customers as much as possible.
Pretty interesting strategy, and I feel like it's pretty unique in the industry. Yeah, you're familiar with a more kind of similar business model approach? Normally, it's kind of subscription or kind of work. Are you familiar with something similar to that?
It's a question for me or for Fei?
Fei.
Sorry, Shon, can you repeat your question? I didn't get it. I thought it's for Tal. Yeah.
So it seems like the perspective of Tal is to open the platform for free for everybody and kind of creating or charging only when it's get to something practical that you can use, whether install or whether to use as a VPP or elements or whatever can be benefits for you. Do you think that business model is something that already has been tried, something that is more familiar in the industry from your perspective?
I feel that this is a very interesting business model, and also it is very flexible, in my opinion. And I think that's a really good one. Regarding whether there is a lot existing or not, honestly, I don't know. So I would not say yes or no to avoid giving any like a wrong impression. Yeah.
Okay, that's fair. Yeah, I think that's if you have further questions, feel free to add to the chat. I see questions about the survey performance, validate the conclusion. Did you see the last question?
Do we have a survey performed to validate conclusion? It's a great point. We don't, but we validate the conclusions by not by survey, aka by asking homeowners, but by observing real life results. So I didn't mention that, but while we're launching the product, the company is about a year and a half old, or shy of 2 years old. But we've been operating with around 30 customers, from solar companies to batteries to generator to community solar and retail electric, and again going fairly wide on the type of customers. And how do we confirm the results is by trying and seeing. We think that home will install solar in the next 6 months, and observing reality whether that home actually did that. So this is what we're doing.
All right, and the last question from Adir is the 257 system also suitable for large facilities such as factories or business, or only residential aspect?
We get this question all the time. It's a wonderful question. We need to focus. Like any business book is telling you that focus is super important, and we're not focusing on a lot of things, many verticals, many territories, many things. But the one thing we are focused is only residential. There is difference between commercial and industrial to resi. There's a lot of differences. The decision maker is very, very different. The economic aspects are very different. The value estimation. There are many things that are different. And for that reason, we're focusing only on resi, but never say never. We may at some point expand.
Perfect. Thank you very much, Tal. Thank you very much, Fei. I think it was fascinating session, and that we got to see from the actual use cases from NREL and the EdgeFlex tool, and what is actually GridFlex and what to measure and how it's operate from Yael perspective to how the consumer behavior can affect and what can be greater to achieve that, and get to Tal and see it for the first time the live demo here of the platform, a pre-release to the pre-release. So thanks, Tal, for sharing with us, and feel free to see that. And thank you all for being part. If you want to be learning more about what we do, feel free to check out this link. You have here all the information. You can register also the community member there. We'll send you all this record afterwards. Have a good day, good evening, good afternoon, whatever you are on the globe right now, and keep igniting the spark.
Yeah. Thank you very much, Shon.
Bye-bye.
Goodbye.
Thank you.
Nice one.
תודה, טל.